Today we're going to look into Wheatstone bridge circuits and how we're going to write this expression for output voltage and calculate how our output voltage or the change in that output voltage is going to be a function of my strain that I apply on the material. So when we look at this Wheatstone bridge, this circuit, which is going to be this kind of the fundamental circuit that we deal with, should look very similar to basically two voltage dividers. You can see it's very similar, almost the same concept here. So we're going to use a same expression in order to kind of write out what is that output voltage. So I am going to kind of label, let's see, I want to figure out this output voltage. And so I need to figure out what's the voltage at position 1 here, at this guy, and position, I'm going to label 2 here. Well, if I want to write the voltage at 1, that looks like just, again, a simple voltage divider circuit. So if I want to find the voltage at 1, here, V1 is just going to be equal to what we kind of saw previously. VI times R2 over R1 plus R2 will be, is just going to be equal to VI times R4 over R3 plus R4. So that is going to be the voltage at 1, positions 1 and 2, kind of in the circuit. So to get my V naught, or actually, we could kind of first think, what's going to happen if we're at balance, i.e. when V naught is equal to 0? Well, V naught is going to be equal to V1 minus V2. So if V naught is equal to 0, we find that V1 is equal to V2. And if you write that out, you'll find that VI times R2 over R1 plus R2 is equal to VI times R4 over R3 plus R4. These cancel out, and you'll get an expression once you run through the math that R2 is going to be equal to R2 times R3 equals R1 times R4, or the ratio of R1 over R2 is equal to R3 over R4. So this is the expression, the relationship between the resistor, again, the resistances of each of those resistors that will give us basically an output voltage of 0, i.e. our Wheatstone bridge is balanced. So there's no voltage kind of flowing across. And you can see this a little bit nicer in my kind of LaTeX notation right here. So if this expression is true, our V naught should be equal to 0. And we know that our V naught is just, again, as we said before, V1 minus V2. So you could write this expression here. And we have our condition, or our output voltage, what is our expression for the output voltage as a function of these resistances for our Wheatstone bridge. That's it. And the beauty of this expression right here is we see if this condition is met, if I plug this in here, we see that my V naught will be equal to 0. So all's well and good in this world, which is fantastic. But now we want to take this circuit. So we want to take this kind of, actually let me draw it a little bit better. Redo that. Still equal to 0. Again, when we're at balance. But what we want to do now is take this circuit, and for certain, certain applications, I want to change, and instead of having resistors here, I want to erase that, and instead I'm going to put some strain gauges here. So strain gauges that are going to be connected through my circuit and being applied to my material, so that when the material stretches, or when a mechanical load is placed, i.e. when the material is strained, we're going to get a strain, or a change in the length of these wires, which is going to correlate to a change in resistance, and that's going to correlate to a change in output voltage, and we're going to be able to kind of correlate that again to the strain that we have applied to our material, i.e. this change in length of either our material or our wires. So that's what we're heading here now. So instead of having kind of this essentially this static problem of our resistors just kind of sitting there, we're going to replace them with strain gauges. We're going to strain our materials, and we're going to see how our output voltage changes. So we're going to take this expression here and ask the question, how does my output voltage change, or how does dV not change if dR1 changes? What happens if dR2 changes, dR3 changes, dR4 changes? What if we have basically a full Wheatstone bridge configuration where we replace all the resistors with strain gauges? So we're going to get into that in the next video. So I'll see you in the next one, and we're almost to a kind of our expression where we could really start to play around with these strain gauges. All right, I'll see you in the next video. Thanks. Bye.